Hi, I'm making this video for Chris Cates. Now, there are a couple ways you can set up your solar, and that is one, the way I have it here, which is all the positives. All the positives are going to a set of junction cables like this, and then going to the charger controller. Now, when you do it this way, you will get the watts, and basically 12 volts, but very little amps. All four of these panels here are more or less producing, let's see, 5.5 amps. So at 100 watts each. So the amperage stays the same. Right here's the watts. Let's see if I can get this camera right there. Watts. Now these say 18 volts max, but they're generally 12 volt. So they do put out 18 volts, but the charger controller handles that. 5.5 amps. Now open circuit voltage is 21.6 volts. Now there's two things you need to look at: the 21.6 and the short circuit current, which is 6.1 amps. You cannot overdo these. Now I want to talk to you about another way to set this up. This is the way to get your watts. I have 4 panels here. Each one is 100 watt. To get amps and volts, here's what you have to do. You take positive, wire it to the negative on this one, positive to negative, and you will have the minus here loose on this end and positive here on this end. Then you take the positive, plug this into your charger controller, go clear down here, plug your negative into your charger controller. Now this is going to be interesting. What this is going to do is it's going to kick in 5.5 amps per panel. Alright, now here's what's really important. You need to understand this. You are sending 18 volts times 4. This will literally kick up your volts. So say if this was 12 volts each panel, which is 18, but I'm going to use 12 because it's easier. That'd be 12, 24, 36, and 48 volts. Now remember, these are more. You find your high number here, max power voltage, which is 18 volts, and you times that number by 4. That will give you the amount of voltage that you're kicking out through your panels into your battery bank, or should I say into your charger controller. Now if you want to get more amps without going over your 24 volt system, I would only use 2 100 watt panels and then run the two. Here would hang down, minus would hang down, positive would be connected to negative here, and then your positive would hang down. So this would be negative going to your charger controller off this side. On your next panel it would be positive, and negative and positive between these two will be connected. That will raise your amps and your volts basically for 24 volts, and you would be getting basically 11 amps. Now you can go way up, way higher with doing it this way, but remember, for every panel you add, like I said, negative, this would go straight to your solar charger controller right here. Positive would come over to this panel, hook to negative, and then the positive on this one will go to your charger controller. Basically what you're doing is making like a horseshoe shape with your cables, and the more panels you have together, the higher the voltage Like I said, if these were each 12 volt, which they are higher. Now consider that. These two would be 24 volts at 12 volts each. But you would also be getting 11, just over 11 amps, just on these two panels. Now, there's one very important thing you have to understand when hooking things up this way. You must, I mean absolutely must, put at least a 10 amp fuse on the positive side of each wire you're connecting between the panels. Now, the reason you're doing that is because if one of your panels shorts out, it's going to send a dead short. Basically, if you say you had 3 panels hooked up and the middle panel went out right here, then this would actually be sending the power to the one that went out, and that would be sending power to the one that went out. That's very dangerous unless you have a fuse on here. If one of these panels goes out, it will kill the whole system, but power will still be going to the bad panel, and they can actually catch on fire without a fuse to regulate it. So a 10 amp fuse on each positive line that you hook up, that is important. Let's get Midnight in here. Okay, if you want your watts and a set voltage, basically this is 18 volts. All 4 of these panels together are 18 volts, but it jumps up the wattage to 100 each. So basically my setup is 12 volt and 400 watts for the panels. If you connect it the other way, you have to have a charger controller strong enough to handle 18 volts times literally however many panels you have. Now, you could use a 24 volt charger controller on just 2 panels here at 18 volts. As long as the charger controller can handle at least 11 and a half, 12 amps. Always add extra amperage and voltage to your charger controller. Make it a little bit higher than you think you need. That way, when it's a super bright day out, real sunny, and the panels are producing as much as they possibly can, there are certain times when they can go over this. I hope that's clear enough for you. I'm not sure. But once again, to get amps and volts, you need to go negative. Just drop your negative line, then positive to negative, positive to negative, positive to negative, and then your positive on the other end goes to your charger controller. So positive on that end, negative on this end. Remember, when you're doing it this way, you must have a fuse on the positive lines. This has its advantages and disadvantages. One of the disadvantages is if it gets cloudy or one panel gets a shadow on it, basically it's going to shut down the system. But when it's working, it will kick out a huge amount of volts and amps compared to having it all positive and all negative hooked on this, all positive on the same line and all negative on the same line. So if you want amps and volts, hook positive to negative, positive to negative, positive to negative, positive charger controller, and all the way down here negative to charger controller. That will kick up your volts and your amps a great deal. But you have to have a charger controller that can handle that type of power. Like I said, on 2 panels, I would say 24 volt charger controller, But if you can get a 36 volt, that'd be even better. They can handle 11 amps without an issue. They do have larger solar charger controllers. They are more expensive. My other panels that I have put up actually produce more power than this. They produce 7.1 amps, I believe. Look on the back of your panels. Find your numbers. The open circuit voltage is 21.6. Your max power voltage is 18. And your amps short circuit current. In other words, what's going to happen if you have it hooked up positive and negative? This has a short circuit of 6.11 amps. Okay? Like I said, if a panel goes out, it'll all back feed into that one panel. That's dangerous. That's why I said you have to have a 10 amp fuse, even if it's an inline fuse of some type, on each positive line. Because if one shorts out, when it starts to backfeed to this solar panel, that fuse will blow and it will stop power from going to this one panel. All right, I hope this helps you out. I hope it helps you understand a little bit more. As far as your solar charger controller goes, on your load can handle 1/3 of the rating of your charger controller. So if you have a 30 amp charger controller, using the load, it can handle 10 amps. So think about it that way. Anyway, that's it. I'm fixing to go. If this isn't clear enough for you, let me know and I will try to redo the video for you or answer any questions you might have. All right, that's it. Bye.